Welcome to the Banker Lamp. Please enjoy the video.
You start by enabling hardware acceleration, open runtime, change runtime type, and pick GPU. Run a quick verification command like NVIDIA SMI. This confirms the system GPU is assigned. If you use PyTorch, call Torch. CUDA is available, so you know your code will see the device. Once done, make sure to restart the runtime when prompted. This secures driver and CUDA availability and avoids stale processes that block GPU access. You now align software to the hardware. Read the NVIDIA SMI output for driver and CUDA versions so you install compatible libraries. Prefer framework wheels built for that CUDA version to avoid ABI mismatches. PIP or Conda can handle that. Once libraries are in place, explicitly set CUDA visible devices if you need a specific card, and in code use Torch. Device, CUDA, or TF. Device to target the GPU. These steps ensure your runtime actually schedules work on the system GPU rather than falling back to CPU. You finish by running a representative workload and watching NVIDIA SMI to confirm GPU utilization. This proves compute is offloaded. Measure performance with simple timing loops and include Torch. CUDA, synchronize. When benchmarking so results are accurate. If performance is low or device unavailable, restart the runtime first. That clears state. If problems persist, reinstall matching framework wheels or CUDA packages because version mismatches are the usual culprit. This single troubleshooting step resolves most.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.